All right, today we're tackling two absolutely massive topics and smashing them together. We're talking about the cutting edge of artificial intelligence and one of the biggest challenges our planet is facing. We're going to see how a much smarter AI might just be a key tool for saving our world. So, yeah, let's get right into it.
So, let's just start with the problem that I'm sure you've all seen. You ask an AI a question, and what you get back is this perfectly worded, super confident, and completely wrong answer. This thing is called hallucination, and honestly, it's the #1 reason we can't just use these incredible tools for really serious work. And look, this isn't just about getting some trivia wrong. When you're dealing with something as high stakes as climate science or biodiversity, an AI that just makes stuff up isn't just unhelpful, it's actually kind of dangerous. This basic lack of trust is a huge wall standing in the way of progress.
And this isn't just a theory. Researchers have confirmed it. When you look at how AI is being used in environmental science, you see these same roadblocks over and over. You've got unreliable answers, not enough specialized data. It just means scientists can't blindly trust what the AI spits out. And that makes it so much harder to connect all that complicated scientific data to the actual policies we need to make.
Okay, so how do we fix it? How do we build an AI that we can actually, trust? Well, the first really big breakthrough to solve this problem was a technique called Retrieval-Augmented Generation, or for short, just RAG. The idea behind RAG is actually pretty simple, but it's super powerful. Instead of just using the information it memorized during training, the AI gets to look things up in a trusted source, like a whole library of scientific papers, before it gives you an answer. It's literally an open book test for the AI, and it grounds it in reality, which helps slash those made-up answers.
Now, this was a huge step forward, no doubt about it. But this first version of RAG, let's call it RAG 1.0, it had its own problems. It wasn't exactly the perfect solution everyone was hoping for.
So here's the problem. These early RAG systems were, they were a little clumsy. They would just grab a set number of documents, say the top 5, and jam them into the AI's brain, whether it needed them or not. So if you ask it something creative, like write me a poem about a robot, it would still go and look up a bunch of facts, which wasted time and could actually make the answer worse.
And this is where the story gets really cool. The limits of that first approach led to a new, way more intelligent way of doing things. We're calling it RAG 3.0. And it's not just a small update, it's a totally new mindset.
Just look at the difference here. We're going from this rigid, kind of dumb process to something that's adaptive, that thinks, and that even collaborates. RAG 3.0 doesn't just grab facts. It asks itself if it even needs facts. It critiques the info it finds, and it can even bring in a team of specialists to figure out the answer.
This huge leap forward is really powered by two main ideas that work together. First, you have self-reflection, which is like giving the AI an internal quality control officer. And second, there's agentic systems, which is like giving the AI its own team of expert consultants. Let's dig into those.
Okay, first up, self-reflection. A framework called self-RAG basically teaches the AI to use these special little notes to itself called reflection tokens. So before it even starts writing an answer, it generates a token that asks, hey, do I need to look something up for this? If it does, it grabs the data. And then, as it's writing, it uses more of these tokens to check its own work, asking things like, is what I just wrote actually backed up by the source? Or is this source even helpful? It's an AI that's fact-checking itself, on the fly.
The second big piece of the puzzle is agentic systems. So instead of having one giant AI that tries to do everything, you have a team of smaller, specialized AI agents that work together. A great example of this is a model called Prism. It has one agent that just breaks down a complex question. Another agent, the selector, goes and finds the perfect piece of info for each part. And then a third agent, the adder, double-checks to see if any important context is missing. It's like an assembly line for reasoning, and the final product is so much more precise.
Okay, so we've got a smarter, self-correcting AI that's way more accurate. That's a huge deal in the tech world. But let's bring this all back down to earth. What does this actually mean for solving real-world problems? Well, let's talk about one of the biggest, the biodiversity crisis. Our planet's ecosystems are in trouble. And to even begin to fix it, scientists and policymakers have to wade through an unbelievable amount of data from every corner of the globe. It's just a massive information problem.
Everybody knows how urgent this is. So pretty much every country on Earth got together and agreed to this massive plan. The Global Biodiversity Framework sets some really ambitious goals. But here's the thing. A plan is useless if you can't tell whether you're making any progress, and that requires a global monitoring effort on a scale we've never seen before.
So, how in the world do you measure the health of an entire planet? Well, you have to break it down into things you can actually count. The framework uses concrete, measurable indicators like these from the UN. We're talking about tracking the exact size of natural ecosystems or counting the actual dollars, both public and private, going into conservation. It turns these huge abstract goals into real data.
And this is where our two stories collide. On one hand, you have this incredibly complex, data-heavy global problem. And on the other, you have this brand new, super powerful, and most importantly, reliable tool for processing data.
So let's really connect the dots here. How can the exact same technology that stops an AI from making up a fake fact about history help us get a true picture of what's happening to our rainforests?
An AI built on RAG 3.0 could be the ultimate research assistant. It could read through millions of pages of scientific reports to pull out the exact data points needed for those biodiversity indicators. It could connect the dots between different studies to build a more complete picture. And this is the crucial part. It could give policymakers a summary where every single claim can be traced right back to the original source document. No more guessing.
At the end of the day, that self-reflection and that agentic teamwork that makes RAG 3.0 so good, that's exactly what you need for this job. The ability to ask, is this relevant, and does the data support this? That's the core of good science, right? We're basically building an AI that can help with the scientific process itself, but at a massive global scale.
And that really leaves us with a powerful final thought. We started this whole journey with a technical problem, an AI that lies. The solution was to teach it to check its own work and to stick to the facts. And now we can turn that exact same ability outward to help us get a clearer, more factual, and more actionable picture of the health of our planet. It's an amazing combination of tech and ecology, and it might just be one of our best shots at tackling the huge environmental challenges that are right in front of us.